Okay. Hello everybody, and welcome to what is hopefully the first in a series of small programming videos. Essentially, I do a lot of crazy, wacky new stuff at Molly Rocket as part of the development of our upcoming game and hopefully future games. And I don't really have any time to write up papers or produce professional quality lectures that talk about some of the newer techniques that I've been trying that I think are successful or interesting. So the goal here is to see if just writing out some sort of makeshift slides on a giant piece of paper and talking about the methods for a while in front of a video camera will be sufficient to get the idea across and disseminate the information, so it's something that I can actually have time to do. So this first one is actually a pretty old idea. It's something that I started doing in 2002, or roughly thereabouts. And it's called Immediate Mode Graphical User Interfaces. And really, it's a style of coding a user interface, or making the code for a user interface of some kind. Doesn't have to necessarily be an application. It could be for a game, application, anything you want. That I think is much easier to use and easier to read and more logical and better laid out than the current mechanisms, which are mostly based around some kind of object-oriented sort of class library sorts of things for user interface design and so forth. So I wanted to go over all of the techniques that in this method and give you sort of the overview, and so that the word can get out and I can see if it's something that a lot of people find useful or something that's like totally specific to my coding style. So first let me tell you why I sort of went down this path. And the reason is because I've done user interface coding several times in the past, and I was never happy with the way it came out. I've done Windows user interfaces, I've done custom user interfaces, I've done X-Windows user interfaces, and sort of invariably the user interface code is always a pain in the butt to write. It's not fun to write, it's annoying. You oftentimes are spending a lot of your time dealing with some crappy widget layout tool and all of these different linkages, different parts of what happens for the UI in different places, callbacks, IDs, all this stuff. And it just always feels like a morass. It feels like it takes way too much code to get a very simple user interface up on the screen. And that was sort of what I was trying to address. I didn't intentionally try to address it. I wasn't set out to try and fix this problem. But what happened was I was working on, at Rad Game Tools, I was working on doing the viewer for Granny, which had a lot of different kind of UI components to it. And as I was working on it, it sort of hit me that the way that I was doing things could be simplified quite a bit. And so I started trying to do some of the simplifications, and I found that just it was kind of just like a completely new, a completely fresh way of coding the user interfaces that was just so much more natural to me. And so ever since then, that's the only way I've ever done user interfaces. So let me go over basically what I think a normal UI library tends to look like, and then I'll show you what that same sort of where everything goes in an immediate mode user interface library. So in a typical UI library, what you have is at init time, the app code, the stuff that you're writing, assuming that someone else wrote the library, that you already wrote the library, the stuff that you're writing is essentially a bunch of create calls. Or maybe you've got some file that you loaded from an editor that has like those equivalents of create calls that define what's going to be created in the user interface. So you might like create some buttons here, create a dialog with some buttons in it, property pages, whatever, you name it, whatever you wanted to create, you've created it. At update time, typically you have no idea what's going on at update time. That's usually the UI code's purview. You don't have any actual code that's executing there. It's not your responsibility. It handles redrawing the buttons. It handles doing whatever. Maybe if you're doing owner draw or something like this, then you occasionally know about what happens in here. But for the most part, assuming you're not doing anything terribly complicated, you don't know what's going on in there and don't care. And then finally, there's usually what happens when you actually need to get information back. The user clicks on a button, the user does something, anything, selects a menu item. You're going to get called back, or you're going to get a message in some kind of a queue. So there's kind of this, in here, some stuff happened that we don't really know what it was, but then we're going to get called back eventually, or get a message that tells us what happened. And then as a result of that message, we might get some information back from the widgets that we want, usually using some kind of ID linkage, like, oh, well, what was that what's the value of this widget right now, because I'm going to go set some variable to be that value or something like this. I might sort of delete or create controls dynamically, or maybe just enable and disable them based on what happened, because sometimes I'm switching to a new property page and I need to do something, or I'm bringing up a new dialog, whatever. So even though we did a lot of creation at init time, we also probably have a lot of creation that sort of goes on in between, and it's unclear where that's necessarily all supposed to happen, but you typically throw it around wherever, what persists when is entirely up to you when you're coding the user interface. Now, for a lot of reasons, this is a big pain in the butt. I won't go into them all now, but I mean, just for starters, the fact that this stuff is also decentralized is usually problem number one. I've got some editor or some code somewhere that's creating these things. I've got some people who need to switch between those things and get values out of them, and the only way they can identify them is by using some ID which is now shared between multiple pieces of code and possibly an external editor. And it's just, okay, it just gets hairy and ugly really fast. The good UI libraries try to do their best to minimize a lot of this stuff, and some of them do a decent job, but on the whole, it still ends up being pretty messy, even in the good case. And in the bad case, like if you're using, say, for example, any of the Microsoft tools, you're in deep trouble. You end up writing hundreds of lines of code that essentially does nothing other than keeping all of this stuff kind of wrangled together. So, on the reverse side here, we basically have what happens in immediate mode graphical user interface code. What happens in the immediate mode code is, much like its name would imply, everything is immediate mode, which means that there is no init code, unless you want there to be some on your end, and there is no callbacks, there's no nothing like that. There's just a main update path written by you. And what that is it's just like you would expect in immediate mode if you were doing graphics or something like that. You go through your code and you start doing the things that you want to do to get your interface up on the screen. So for example, I might do something like if do button, right? Let's say that this was going to be a button. I might call the do button thing, and it's going to return me true if the button was clicked or false otherwise. So if it was clicked, then I'll just do whatever I wanted to do when that button was clicked right here. There's no need for a callback, no need for anything else, I'm just going to do it. And if not, then I won't do anything with that button, but I mean I still drew it on the screen by using this call. And then I could do other things. I could have ifs that say, oh, if this state is this, then I'm going to do this. Or I could do some kind of switch or call a function that does some other parts of the UI if I want to. I can have for and while loops. I can do a while loop and draw a button on each loop, whatever I want to do. And it's exactly akin to what you would do if you were doing immediate mode drawing, right? You typically in immediate mode drawing, right, you don't need to have init code that sets up all the stuff that you're going to draw, and then you just magically go draw, and it all draws itself. No, you have an update loop which pulls from your data, not some data that's defined by the renderer, but your data, and you decide how the user interface gets done on each update yourself. Okay, that's basically all there is to it. Now, granted, I'm going to have to explain a bunch of other things because this may look totally strange to you, and that's understandable. This isn't the way user interfaces are normally coded, but honestly, really, despite the fact that I might spend 20 more minutes talking about this, that's the only key difference between immediate mode user interfaces and standard user interfaces is they're just trying to do what immediate mode graphics did as compared to retained mode graphics. Because we all pretty much know how hard retained mode graphics suck. That's why we use immediate mode graphics. Same is true of immediate mode user interface. I think regular graphical interfaces which are retained, you do inits, you have them, they know state, they know what their button is, whatever. I think those suck, and immediate mode graphical user interfaces are kind of the answer, in my opinion. Okay, so how does this stuff actually work? How do you actually do code in this manner? Well, the primary idea that motivates how this stuff is going to work, and again, this is just one implementation. The core idea I've already said, so there's a million different ways you can implement this. Here's how I tend to implement it. The core structure is called the UI context, and what that does is that tracks the state of the user's interaction with the system at any given time. Now, there's a key point here that I think a lot of people fail to realize about user interfaces, even complicated ones. And that is that there's a massive, massive amount of redundant state typically stored in a retained mode graphical user interface. It's not uncommon at all for something like, say, an edit box in a user interface to retain all of the information necessary to edit the information in that edit box, even though the edit box is not being engaged by the user in any way at a particular time, right? So if I have two edit boxes on the screen, the user cannot be editing the text in both edit boxes at the same time, obviously. However, both edit boxes typically carry out all of the baggage that they would need to do so, even though one of them, the one that's not being interacted with at this time, only needs to know the text. That's all it needs to know, because that's all it's doing. It's just going to draw that text. It doesn't need to know anything else. But it still probably carries around, stuff like, oh, what was the mouse state? When was the last time I clicked on? All these pieces of data that it would need to interact with. That's fine. We're not really concerned with memory so much in graphical user interfaces. Typically, that's not that big of an issue. Although those of you who have ever used Visual Studio may have noticed that sometimes you click on something and it says, this may take a long time to expand, or are you sure you want to do it, or things like that. So I don't know, maybe sometimes you are. But for the most part, you're not. So I'm not trying to say that that's a bad thing. The point is, that redundant state is actually something that can be exploited to make a much more efficient piece of code that's simpler and easier to understand. And what that is you can say, well, you know what? The user can only be interacting with one thing at a given time. So let's just make a single structure that's kind of global to the user interface. That's the state of the user interface. That is the state of the user's interaction. Because really, that's all we need. We don't need anything else. Everything else is data that's coming from the application, and that application is storing that data in its own way. The text in an edit box should not be stored in the edit box. The text that's there means something to the application, and it is stored in some application data structure. So we clearly don't need all of that. So what do we actually need to store in the UI? And the answer is just the minimal amount necessary to interact with it. So I'm going to go over the simplest set of interactions that you can do, which is a button or a menu item. But this extrapolates to basically any kind of widget that you want. Now, what I've done here is I've shown the two most important members of this UI context, which is what is the hot item in the user interface and what is the active item. Now, basically, these two things are using what's called the UI ID struct, but really all that means is some method of identifying the item. And I'll talk about what that means in a second here. But we have two things, hot and active, because typically user interface elements have sort of two states. There's about to be interacting with this item and actually interacting with this item. If I'm about to be interacting with the item, typically that means like I move the mouse over that item, let's say. Or I'm using a keyboard interface and I've highlighted the item. So it typically means the item wants to draw itself highlighted or show up in some way that suggests to you that, hey, you know what, maybe you want to interact with me right now. Maybe not, but maybe you do. Then, if the user actually starts the interaction, they click the mouse on it or do whatever it takes to get that widget going, then that's an active item by my terminology here. So hot means like about to be interacted with, and active means I'm actually interacting with it. Okay, and we'll see how we use these two things in a second. But that's basically the majority of the information that we need to store for basic UI. Now, the way that we identify items is kind of interesting in immediate mode UIs because it has a very different property from the way that we identify them in standard UIs. In a standard UI, the typical reason that you have an identifier, like I showed on one of the previous slides, was because there are different sections of code that need to talk to each other about a particular item. I created the item over here, but I need to access the data from the item somewhere else, right? Make sense? In that case, what you're talking about is some globally unique identifier that is set up beforehand or whatever, however you want to do it, right? For immediate mode UIs, we don't really care about that so much because of the immediate mode nature of it. We can always handle all of the interrelations, the complex interrelations, on the app side because it's all using app data. We don't have to have there be ways of getting that information out of the GUI because the GUI is not storing any of that information for you. It's all clean and on your side. So we do need identifiers, however, because we need to remember things like what element the user was interacting with last frame, for example, or even this frame. So we need a method of identifying them. So typically what I do is I don't want to actually have to make a header file with these IDs, and I don't want to have to make them globally unique. I don't want all of that headache that's sort of associated with the old way of doing the user interface stuff. So what I do is I typically use just kind of when you call in to do a button action or any of that sort of stuff, you just pass in some bits of information that will uniquely identify you. And this is almost always readily available to you, except in very complicated scenarios, which we could talk about later. So in the basic scenario, let's say I'm just doing some buttons and so on, and maybe when I do a button, then I'm going to go call some function that's going to do some stuff, right? For the global identifier for that button could easily just be the function pointer, for example, right? Because we know that that's globally unique, and we know that any user interface element that is going to be interacted with that's going to do this action, we probably want them to always share that, so that way, when one of them becomes hot, then multiple of them could light up, for example, just so you know that they're the same activity. Of course, normally you don't want user interfaces that have lots of buttons that do exactly the same thing on them, but that's not the point. And furthermore, sometimes you want to be very specific and have even two things that basically do the same thing or have the same meaning be separated in terms of the hot item and so on. So sometimes you keep more information out, which is like, for example, the owner, which is like, oh, when I went in to draw this group of user interface elements, I'll use the pointer to that function, or I'll use the pointer to the data that I was being driven from for that group of items, like the menu or whatever. I'll use that as well. So they're just basically pieces of blind data that the application passes in. Index is another one in case I was doing an array of things, whatever. And it's very, very similar, again, continually drawing comparison, very, very similar to the way it would work in a medium mode graphic system when you need to get feedback from the hardware or from the library. For example, feedback buffers, that sort of thing. The library does not care how you want to identify these things. You can use any identifiers that you want. It's just there so that you can uniquely pick out a particular item. So, here's an example of, this is code in the UI library. So this is not code that you would be writing unless you were implementing the library. This is the code that you'd be calling. So I talked about do button, and I was saying that it returns a bool, which is true if the button was clicked. So you know to do something when you called it, right? And the example here, you pass in the context, obviously, some piece of identifying information, and again, that's your decision, but the struct, that UI struct is an example. Say the text of the button, I don't know, and some other crap. Maybe where you want the button placed, I don't know. Maybe there's some auto layout happening, who knows. Again, all of that's dependent on how you want to implement your library. But the logic is incredibly simple. Basically, we just say, if we're the active item, and in order to determine if we're the active item, that's a call that usually goes into the UI context, which compares our ID versus the active ID. And if they're the same, then we're the active item, and if they're not, then we're not the active item. Very simple. If we were active, then if the mouse went up, meaning the user released the mouse button, if we were hot, which again is the same as active but a different ID in the context, so just compares against that and says it, that means the user was still over us. Then the result of this interaction is true. So we're going to return true, and eventually when we fall out of here. And that's going to go ahead and tell the calling code that it's time to do the activity for this button. If we weren't active, then if we were hot, okay, skip one here. Regardless of what happens, when the mouse goes up, we set ourselves to not be active anymore. That's because the definition of a button's behavior, of course, is when you click down on it, then when you release, if you released on top of the button, meaning it was hot, then the result is true. If you released away from the button somewhere, then you don't consider that a click. It's a standard UI thing. Obviously, you don't have to do it that way, but that's kind of the convention, so it'd be weird if you did something else. Your users would get a little confused, although many games often don't implement that correctly. What are you going to do? Now, okay, so if we weren't active but we were hot, then we just need to know, did the mouse go down? Did the user click? Because if the user clicks while we're hot, then we become active, right? Because we were about to be interacted with as a button. We know the user was over us because we're hot, so if they click on it, we become active, and now we're the active item. And now we're going to be in here next time the user interface does something, and maybe the mouse will go up and we'll be able to return true. And finally, regardless of what happens up here, if the mouse is inside us, if we were the hit region, which presumably the user passes where we're supposed to be here, then we set ourselves as hot. And the way that works is we call into the UI code and say, set us, we're the new hot item. What that does is not directly it doesn't directly set it as it does with the active thing. Right here with the mouse down set active, which usually just directly sets the thing as active. When we do the set hot, it looks to see if there is an active item. If there is an active item, it doesn't set us as hot. right? Because that item is being interacted with, and we're not going to be hot, right? If there's an item being interacted with and you move your mouse over other widgets, they should not become highlighted or anything. So this is simply a request into the UI system. If there was no active item, make us the hot item because we are hot. Finally, after this, I haven't written anything in here, but this would presumably draw some stuff for the button and whatnot as well. You display the button however you want to display it with a frame around it, draw the text, who knows, whatever. Same exact code you would have in a regular graphical user interface at the time when it's time to code it. So again, this is not something that you write on the app side. This is something that the library is doing, and it's a function that gets called by the calling code. Very, very simple stuff here. Okay. So, you can imagine more complicated widgets than just that, that require more than just hot and active, like a button does. But there's a surprising number that actually do that. Scroll bars are pretty much the same. Most of these things are pretty much the same. The only difference is some more complex ones, which are like edit box, text edit boxes, and so on, will require interim information like where the cursor position was and what the hot selection region is and that sort of thing. So sometimes you have some widget-specific data that the UI context will store for that widget during its active period. But again, I wanted to keep this relatively simple, so I'm not going to go into how that stuff works. It's pretty easy to extend to do them. So I just wanted to show here the example of just kind of draw out some more parallels between how you use this code and how you use graphics code. Immediate mode graphics code looks, like, for each object and each batch in the object, I'm going to set the material and draw some triangles, and then maybe I'll do the transparent ones last, and I'll sort them and do some batches there. Or, maybe this gets kind of complicated, and I do some checks, like if something was called, then I'm not going to draw it. Maybe I call batches. Maybe I've got some kind of a BSP I'm traversing. Who knows? This is entirely in the app side of things, right? This code does not live in the renderer. That was a very important part of the progress of graphical, graphical coding, is realizing that retain mode was not a good thing, because the way that the app needs to express how things get drawn is necessarily going to look like this. It needs the flexibility there to do whatever it wants, because each game or each application is very different when it comes to exactly how the flow is going to work. And so UI is no different, in my opinion, and you get the same sorts of things. Like, I want to just be able to say, for all the menus and the items in the menus, I'm going to do an item. Or maybe I have this as kind of a thing which I just call for do menu, and I can do the same thing for pop-ups if I want to, and I can make sure that I do those after, or I could do them during, or whatever. And I can do 3 elements too, it doesn't matter. I can do anything I want to do here. And again, this is totally up to me how I want to do it. I can do culling, quote unquote, meaning if at any time I don't feel like drawing some of the items, I just don't draw them, right? I just don't call do item, which gets rid of the user interactivity of them and gets rid of their visual representation. I don't have to delete the item, I don't have to disable it, I don't have to hide it, I just simply don't call it that frame. Furthermore, I don't even have to know how many of these there are, I don't have to create ones for it ahead of time, I don't have to do any of that stuff. I can iterate over my own internal data, which could be any format I want, generate UIs out of that, right? I could load a file and generate the UI right from that file. I could do anything I want to do. It's entirely up to me, and the same library can facilitate all of that. The library does not have to be aware of how I'm deciding what widgets are on the screen, and when, and how they're being interacted with, and why. None of that stuff has to be known by the library. The library simply provides you a number of potential interactions and potential ways of drawing those interactions, and you call them when you want. That's the whole idea. And a lot of the power. So, some stuff, let's see here, reasons why this is cool and why I like it a lot better than the previous method. For starters, there's a single piece of code for every logical piece of your interface. It's not broken up. It's not broken up between an editor, some init code, some response code, etc. There's no breaking up of it. It's all in one place. If you wish to load something from a file, you could, but that's entirely optional to you. For the most part, all you have to do is just write a single piece of code which encapsulates where something's drawn, how it's interacted with, and what you want to do when that interaction comes through. It's all in one place. No matter how complicated it gets, it's all in one place. And that's very important because it keeps the code much cleaner, and it makes it much easier to edit when you know that if you want to edit a particular piece of the UI and change its behavior, you only have to go to one place in your code. It's not scattered. right? It doesn't lead to code proliferation. There's not an object per widget. There's none of this stuff. It's all very, very straightforward. And similarly, kind of going along with that, there's unified flow control, which means that the graphical user interface library is not in control of what's happening at any time. It is in a regular user interface. It's got kind of an update loop that's going to do, and it's going to sort of either call you back or do message queuing back to you and so on. That does not happen in the immediate mode system. You are always in control in the immediate mode system. You have a single path for your UI that works exactly the way you want, that mirrors the structure and behavior of your app, and then you're always just calling out to the library, and it immediately returns back to you the information that you need to process the activity there, right there. There's no synchronization, which just comes with any immediate mode system, which is nice. And this is including existence, like including whether or not things actually exist on the screen or exist to be interacted with. There's never any synchronization that happens. And that's very important because typically a lot of the overhead in user interface stuff also comes from this ridiculous amount of synchronization. Calling all these set calls, enabling this, disabling that, putting this here, making this that. It's like none of that stuff happens at all in immediate mode user interfaces. If your code executes and it calls out to display a particular property page, that's what gets displayed. If you don't want to display that one next frame because some variable changed, which has nothing to do with the user interface, maybe it was like some variable that changed because like 10 seconds went by, whatever you want, or some character did something on the screen. Doesn't matter. You just call a different thing that frame or don't call that function at all, and the property page disappears. Poof, no problem. So it's really nice that way because now you only have to worry about your own part of the code, your own logic. You don't have to worry about making sure that your own logic can be mapped onto the UI logic in some way, which typically is a huge headache and involves a lot of extraneous code that is boring and really contains no valuable information. Okay, so those are kind of some things about the actual coding process. Now, one of the nice things about this in terms of as UIs get more complicated is this this style of coding scales really well to very complicated widgets with specialized behaviors. And that's something that standard UI libraries handle very poorly. So I'm going along and I'm using, some of the things in my UI library, and then all of a sudden I want to do something complicated that's, a very specific kind of widget that only my app's really going to have. Typical UI libraries handle that incredibly poorly. But immediate mode libraries, that's really no problem. Because it's trivial for you to just do some of your own interactivity and your own widget coding right there, anywhere you want, or even add your own function calls that you call out to that are kind of your own secondary library. Because all you have to do is make sure that it plays well with the active and hot items, or if there's some other items there that you depending on how you structure your UI context. As long as you can make sure that it doesn't step on the toes of that, which is trivial to do, then you're fine. You just, as soon as you feel like your widget became active, you set to the active item. Everything else in the UI is shut down until you release that activeness. So you can write any code that you want. It doesn't matter what. Don't care how you render it. Don't care what you're doing with the mouse. Up to you. And similarly, it scales well to the relationships between items. Because, which again is something that's very poorly handled in typical UIs. If you want to do all kinds of crazy stuff, rearrange the orders of buttons, hide huge sections when something's checked off, only show something when a particular item is set to a particular value, those things are as simple as the code necessary to check them. If you want to only display some huge set of widgets when a particular value is set to 5, it's an if value equals 5, open brackets, do all the items. That's all it is. It's just wrapping up the code in one if, right? That's the way it should be, because you're not asking to do anything complicated. Normal widget libraries typically make this kind of thing incredibly complicated. They involve you having a callback on the change in that item where you check to see if it's that, and if it is, you call to set the other widgets to something else or remove them. It's just a disaster. In immediate mode GUI, no problem. No worries whatsoever. Now, these are particularly of interest to game programmers, I think, or people who write 3D editing applications of some kind, which is that immediate mode GUIs really integrate fabulously with pieces of code that don't actually have any knowledge of user interface or don't even want to be involved in user interfaces at all. Say, for example, your rendering library, your animation system, all of these things are typically not written with user interface in mind. But almost always they have some way of doing, say, for example, ray picking, and they can always render themselves. And that's all you really need to turn them into an immediate mode widget. because all you have to do is you just have to go, okay, well, I'll make my own little do button behavior kind of function, and instead of using is inside rectangle as my test, I can just use did the mouse hit this item using the picking call of my renderer or whatever. And that stuff just integrates perfectly, because you can do it in the middle of some very complicated rendering loops that involve setting the camera position and all these sorts of things. All of that stuff you can just write the way you would normally write it all in the middle of your normal application, and you can just make the immediate mode GUI calls right there, and it just works. So it's really, really easy to tie any other complicated code into the immediate mode user interface. That is extremely difficult to do in typical UI systems. It often involves deriving from somebody's class and hoping that they have enough messages or enough data things or whatever, God only knows what the hell's in there. Hoping that that stuff will facilitate your ability to do what you need to do. It almost invariably doesn't. You don't get the callbacks at the right time. You have trouble setting up all your context things. It's just a disaster. To the point where even in professional 3D applications, oftentimes you have two totally separate systems running the user interface, one for the 2D user interface, one for the 3D user interface. That's crap. Why? There should not be two different systems. It's just a user interface. And immediate mode GUI lets it be a single system. Single path, no problems. Finally, immediate mode is perfect for real time. As you might imagine, immediate mode and real time hand in hand. And the reason for that is that you're passing down everything every frame. You're going through the user interface every frame and drawing it while you're interacting with it in your own code. So if you want to do crazy stuff, like have your animation system animate some guy and it puts the frickin' button on wherever his, above his head or something, no problem. Because each frame you just get wherever that position was out of the animation system and you call the draw button code right there. And it just magically works, right? Again, no synchronization issues. You can simply do a single path where you would normally be doing all your stuff, and you can just put the calls to the interface right in there. And you don't have to worry about all these sorts of normal partitioning problems that you would otherwise have, which make this sort of thing incredibly difficult. And so I think that that part is actually really interesting, especially going forward, when a lot of times now people, even for simple user interfaces, I think partially thanks to like Mac OS X, for example, and also Flash on the web, people are looking to make sort of more glitzy user interfaces, which have more action on the screen. Things floating around and moving and doing all these crazy things. That creates enormous problems for today's typical UIs. Immediate mode GUI, no problem. It's made for that. In fact, it does that better than the stationary stuff. Because, hey, stationary stuff doesn't use part of the power of the immediate modeness of it all. So I think there are a lot of really compelling reasons to use it. Now, that said, obviously, there are drawbacks. Whenever you switch from one thing to another, you're making trade-offs. And in immediate mode GUI's case, I think that it's overwhelmingly in favor of immediate mode GUIs. However, there's definitely some trade-offs that you should be aware of. And primarily where these trade-offs come from is in the fact that particularly the languages that we use, which are like, for example, C and C++, which is what I primarily use, what most game developers use, what most developers use actually, I guess, until you start getting into more of like webby kinds of things or whatever, is that C and C++ do not respect the fact that code is also data. C and C++ are notoriously bad languages for things like introspection, for things like understanding where I am in my code and so on. C and C++ can't do anything, resembling anything, for those sorts of situations. No closures, no introspection, no nothing. You're flying blind, essentially. And what that means is there's really no way for you to have code that thinks about the whole UI in any real way. It cannot traverse it in any way other than actually just calling it, right? You have to actually execute the UI to know what the UI is. And that's where a lot of the power of immediate mode graphical user interfaces come from, but it also means there are some drawbacks. For example, anything that you want to do that's based on layouts or looking at the size of the total UI and then doing something based on that size, anything you want to do regarding that has to be one frame of lag. Because in order to look at what happened at the end of all the layout, you have to actually have called the code. Now, there's some ways that you can code around this, which is to make it so that your code can be called And the UI context, which again, the slide is gone, but that UI context stores the active and hot items, that can store whether or not you're on a render pass or on a layout pass. And it can have the functions respond accordingly. So when you call do button, if it's in layout mode, it will just record its size and send that to the layout engine or whatever. Those things can be done, but again, that starts to get a little more complicated and introduces some more complexity there, away from the pure simplicity and ease of implementation and ease of use that come with the immediate mode graphical user interface. So I tend to prefer to just kind of like let that stuff slide, because very, very rarely is there anything in a real-time application that can't have one frame of lag and be fine with it. So I tend to just accept that. But if you really don't want the one frame of lag, there's ways you can make things work. But I'm not super into that. I don't directly advocate it. That sort of thing, on the other hand, is not a problem for retain mode things, because retain mode things can loop over their stuff. The sort of code that's in charge can loop over it as many times as it wants. And that's kind of a little more powerful in that sense. Either way. Other than that, I don't think there are really any drawbacks in immediate mode GUIs. There's just that one, but that leads to some problems. Most everything else is a clear win when going from the graphical user interface of today to an immediate mode graphical user interface. I think you pretty much get all wins. The only other one I can think of is that it becomes a little more, there's a little more onus is on the application if you want the user interface not to update every frame. So for example, if for some reason the user interface is very complicated and drawing it was a big deal, so that you didn't want to have to draw it every frame, you only wanted to draw the parts that changed, for example, that becomes also much more difficult because you're kind of counting on code flow to generate the user interface in the first place. It's hard to isolate things and do changes. So again, the app side ends up having to be more responsible about that sort of thing if they really want it, because they're the only people who can really do anything about that. And that's kind of akin to what happens in 3D app with culling and so forth. The application is responsible for doing those sorts of things at the course level. And the same would be true of IMGUI. So again, a couple trade-offs there. So in closing, I think there's a lot of really compelling reasons to use this, and I hope that people experiment with it as I have, and I suspect that as more people use it, if it becomes popular, then there will be a lot more things that people find out that I don't know about yet, because I've only been doing it in my, for my limited uses, and I've only figured out the things that were apparent to me. I'm sure that as other people use it, they will figure out more things and come up with more clever ways to make this stuff work. Standard graphical user interface libraries have had many, many, many years of evolution, and this has only had, basically my time which has not even been dedicated to it, and it's already gotten pretty far, which makes me think that it's a decent way of doing things because it's so easy to make progress there. But I'd love to see what would happen if a lot of other people started banging on it and coming up with their own ways of doing things and making standard libraries and so on. I think that would be really cool. In terms of more information about immediate mode graphical user interfaces, I know that Sean Barrett is going to be writing up some articles in Game Developer magazine on immediate mode graphical user interfaces. I don't know very much about what he's done along these fronts. I don't even know exactly how much our two styles of doing immediate mode graphical user interfaces have diverged since we last talked about them. But that would be a great place to look because I think he's going to do a much more thorough job than I did. I know he's going to, put together some code for that so you actually see how his implementation actually runs and take a look at it, and he's going to actually write some articles that go into it in depth much better than I've done here. So definitely look for that. Game Developer Magazine, I think their website is www.gdmag.com. And I don't know if Sean will post them on his site, but his site is www.nothings.org. Either way. And I also think that maybe there might be some commercial libraries coming up in the future that will do this. I know that some people are possibly thinking of it, but I don't know what the status is on that. Hopefully that would be really nice to be able to have a commercial library that was doing it, but I don't know what the status of that. Hopefully that'll happen. So that's really all the information there is. Again, I haven't done much to disseminate this, and I apologize for that. So as a result, there's not that much available about it. There really aren't any articles. The only people who I know who've done anything with it are people who I was, kind of talked to about it and who thought it was cool just from, a cursory description. And so I think that, hopefully there'll be more about it coming out soon that you can get your hands on, but I can't really point you to it at this time. So that's about it, and this will all go on the Molly Rocket forums at www.mollyrocket.com, MOLLYROCKET.com, and /forums. Down in the lectures forums, so that you can discuss it. You can ask me questions if you want, or ask other people questions on there. And sort of, if there's things that I didn't cover, and this is very cursory, hopefully I can clear up some things in there that I haven't touched on and so forth. So I hope to see you on there, and I hope you enjoyed this kind of makeshift presentation.